Yeah, vector functions and their derivatives, vector valued functions or vector functions, so you might see vector valued functions, same thing. It's a function whose domain is a set of real numbers and whose range is a set of vectors. So we're going to try to find the domain of this vector function here. Okay, when we're trying to find the domain of this, we're really going to look at these as two separate pieces. So let's write this as f of t is the first piece, the natural log of 3 minus t. And then we're going to let g of t be the other piece there. When we're talking about vectors, do you see how the r here looks bolded? That's because it is, okay? With vectors, whenever you're writing a vector, you write it as a bolded thing. So when you see a bolded letter, that just means it's a vector, okay? So this I is actually a vector. It's the vector 1, 0. And j is also a vector. It's the vector 0, 1, which we'll look at a little bit more later, okay? But if you notice the bolding, that's what it is. In your homework, when you're writing a vector, just trace over it a couple times quick because it's a bolded letter, okay? So we're trying to find what the domain is of this chunk. What's true about natural log of something? It has to be what? Always positive. So this 3 minus t has to be greater than 0. Can it equal 0? No, you can't take the natural log of 0. So this is what we've got here. We would subtract the 3 over and then do what? When you divide or multiply or divide by a negative, what do you have to do? Does anyone remember? You have to flip the sign, okay? And if you forget to do that, hopefully at the end here, you're going to check to make sure that this makes sense. So if we plug something less than 3 into here, does it seem like it works? Yes, right? If we plug in like 1, that'd be natural log of 2, which is good, right? If you plugged in something greater than 3, like 7, it'd be like, oh, there's a negative in there. That's an issue. Okay, and if you don't solve it this way, if you just can think about what the domain is, that's completely fine. I just know some people have trouble with that. Okay, over here, what's the domain going to be? Can it equal 0? Yeah, so greater than or equal to 0. Okay, so we'll write ourselves a note because this is our notes that we'll use possibly again in college next year. So the domain of your vector R consists of all values of t for which R of t is defined. Okay, so therefore our answer would go from where? So if it's less than 3, and we have to have it also be greater than or equal to 0, what's my actual domain there? 0 to 3. And which one do I include? We're including 0, and we're not including 3. So when we're including 0, you put the box bracket. And when we're not including 3, you put a rounded bracket. So that's one way to write it. Or you can write it, the other notation would be we're going from 0 to 3, t's in between, and it's greater than or equal to 0 and less than 3. Okay, so this is fine or this is fine. Those are the exact same answer. What? Okay, so the other piece over here, we're trying to find the limit of the vector here. The nice thing about this is it's probably what you would do without even learning the lesson. If you're trying to find the limit of this vector, you're going to find the limit of each of the pieces of the vector. So we'll write it here again for the sake of our notes. So we're taking the limit as t goes to 0 of our vector r of t. So if we're taking the limit of that, we take the limit of each piece. So we're taking the limit as we approach 0 of 1 plus t cubed. and that's my I part. That just means it's the first part of your vector. So there's two ways you can write vectors. You can write vectors like this, where you do like this weird bracket thing around the outside. That means it's a vector. And this is the first part, and that's the second part. That's what this is saying, is this is the first part, that's the second part. So this could have been written with those weird brackets and no I and no J with a comma in between. Okay, they're the same as each other. So this part here is the I part. And then we're doing the limit back here of sine of t over t. And that's the j part. And I stated this kind of towards the beginning there. What your I is equal to is 1 comma 0. So if you took this times 1, 0, it would just fill in the first part because the 0 part would cancel. And j is 0, 1. And if you took this times 0, 1, the first part wouldn't go with this, but the second part would go with that. So it's just saying this is the first part of the vector, that's the second part of the vector. So we have to find what those limits are, which some people are good at and some people aren't so much. Go ahead and try to find those limits so we can get our answer here. These ones are pretty basic. Okay, so what do we get for the first limit up there?
1.
We just get 1. That one's really easy, right? So this part here is just equal to 1. Okay, now if you plug in 0 here, what do you get? You get 0 over 0, so therefore L'Hopital's applies. So if we're applying L'Hopital's, what's the numerator going to turn into? Cosine of t, and the denominator turns into 1. So if you're applying L'Hopital's, you get cosine of t over 1, and you plug 0 into that, and you get 1. So this part's also equal to 1. So if you need to write yourself, you know, a little L'Hopital's note there, that's fine. So this just turns into 1i, which is just I, plus 1j. So that's your answer. You can write it like that. Or the other way to write it is 1 comma 1. Okay, same thing. So questions at all? Just pen back. Okay, so here it says sketch a curve with a vector equation. When we're given a vector equation, this first piece is your x equals, and the second piece is your y equals. So we've got x equals 3 cosine of t. And we're going to do this without our calculator. And then we got y equals a 2 sine of t. So what we were doing in the last lesson is what over here? Yeah, you pick your t values, and then you find your x and y coordinates that go with those t values. So let me just give you the t values I have on my paper here. I've got 0. I'm going by pi over 4, as it looks like. I tried to just go by pi over 2s, and you couldn't get enough points to actually see what was happening fully. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, so on. And then go ahead and find the x's and y's that go with that. So like when you're going at pi over 4, you get square root of 2 over 2, so that'd be 3 square root of 2 over 2, right? And if we do that in our calculator, according to my paper, we get about 2.12, because when we're plotting that, we'll want those decimals. Over here, square root of 2 over 2 times 2 would give you just square root of 2, which is 1.41 about. 3 pi over 4, it's almost the same thing except for this one's what? Negative, so we get negative 3 square root of 2 over 2. I'll just write the decimal for plotting purposes here. And this one is positive, right? 5 pi over 4, they're both negative. And then 7 pi over 4, positive here, negative here, seem right? And do the other ones look okay? Did you guys double check those? Okay, then we're going to plot the points, so you just plot the x and y. So it looks like our x's need to go up to 3 and down to negative 3. So I suppose this can just be 1, 2, 3 here. And we'll just do the same, 2 going here, just by 1s. You guys can make yours look however, but it looks like it needs to go to 3 for the x's and 2 for the y's, positive and negative. Then plotting some of those points here, so 3, 0, that's your first point. Then 2.12, 1.41 would be about here. 0, 2. Same idea over here, that symmetric point. So what is this creating? An ellipse, right? And then it goes back to this spot, and it would just continue to go around. A lot of times. Yeah, we would put it on there, so we'll get that here. I'm just going to do the sketch quick here. Just a quick little ellipse sketch. And then, yeah, your arrows would go this direction. They don't really test the whole arrow thing of it, so it's not going to be the end of the world if you don't have them, but there is definitely a direction with these. Okay, so we've got that piece. It should be pretty good. I suppose we probably could write an equation for the Cartesian, but that wasn't part of the question, so it might be kind of difficult, so we won't do that here. Last page here, this is the page that I think is the most difficult. So when we're looking at this vector equation of a line, what parts here are bolded? So what parts are vectors? No. Yeah, R naught, and V. So make sure you realize that those are actually vectors. So find vector and parametric equations of a line that passes through these 2 points. So let's start by kind of plotting those 2 points over here. So we got, yes you do. I thought it was on there. Okay, you guys will have to do it yourselves. That's true, yeah. Okay, so you'd have a point at 3, negative 2, and 5, 7. And we're talking about a vector. So I know some of you might know what a vector is, but some of you might not. Okay, yeah, vector, it has, if you've ever watched Despicable Me, okay, it's got both direction and magnitude. You know the guy's name's Vector? Yes, I just watched that like yesterday or the day before. I was like, I'm going to be talking about vectors. So we're starting here, and the direction, I'm assuming it's going from A to B. It doesn't really say. It could go the other way. We're just going to go from A to B. So your direction would be from A to B, so it would have an arrow on this side. And then the magnitude of a vector is what? Anyone know? No, try again. It's the length of it, okay? So that will actually come into play later on here. So let me just put these points down here. We got 3, negative 2. And 5, 7 is up here at B. Okay, so how many vectors would you have that have the same direction and the same magnitude? Yeah, how many could there be? Infinitely many, right? Because couldn't you really shift this if we cloned it? You could shift that anywhere on the coordinate plane. So a lot of times it's easier to think about it starting at 0, 0, and then landing right up here. So some people think of it that way, which makes the problem easier for them. And it depends on what the problem's asking, but sometimes shifting it to the origin makes it a little bit easier, okay? Okay, so what we're going to do is we're going to write ourselves little notes here. That way when you're doing your homework or reviewing this for your test, you can remember how to do it. So to find a vector parallel, this is parallel to AB. If you don't like that, just write parallel there. Okay, now when we write AB, if it was a line segment, we'd put a line segment on top of it. Because it's a vector, we're going to put a vector on top of it. We're starting at A, going to B, so our arrow goes on the B side over there. And you maybe have seen a vector, I know in some books they do vector notation like this, with just the top half. Have you guys seen it like that? That's not, something they're going to test on the AP test, but you might see it like that instead. That's fine if you want to use that notation. So to actually find the vector that's parallel without having to graph it like this, because what I did is I graphed it, and I'll show you what this means when we get it here. You are finding your V that goes into here. You take your bigger point or your second point and write it as a vector. And then you subtract your initial point there. And all you do to subtract vectors is you subtract the first pieces and then you subtract the back pieces. So what do I get if I subtract the first pieces? 2. And what do I get if I subtract the back pieces? 9. Okay, so what this tells us is we're going to the right 2 and up 9. So could you have done that if you looked at the graph here? You're going to the right 2, you're going up 9. Or if you shift it and look here, the coordinate that would go with that would be 2, 9, right? So there's different ways to do it, but really you can just subtract those two and get that. Okay, then the next thing here is we can use any point on AB. For our initial position, or P naught, that just means initial point. Okay, so when we're doing this up here, so now I'm starting to use this formula. I've got my R, and I'm going to say R of T, but you could just write R if you want to, equals our R naught plus T, and our V is a vector. What am I putting in for V? 2, 9. So I'm going to put that into that spot. T is my variable, so I'm going to leave T as T. And then for R naught, that's like this part here. You can use any point for that initial point that's on this vector. So most of the time people just use the initial point down here, but really you could pick any point on there and it would be correct. So our initial point we're going to use, just to keep it nice and simple, is 3, negative 2. And for our V, we're putting 2, 9 in that spot. So now if I take my first pieces, I get 3 plus, what's this going to turn into? It's like distributing it, 2t. So 3 plus 2t is the first part. And then comma, what's going to go in the back part? Negative 2 plus 9t. Okay, so you can write it like this, and that's fine. Or how can I write it with i's and j's? So you put the 3 plus 2t, that's your I, plus, and then you do the negative 2 plus 9t, and that goes with the j. Okay, so it's fine to write it either way. Usually people write it this way because it's, quicker, but they might write it the other way on the AP test or something. Okay, so if we had to come up with what the parametric equations are with this, it'd be what? So 3 plus 2t is your what? X. So when it says find vector and parametric equations, we just found vector equation here. Now we're finding parametric equation by just having x be the first piece. So this is actually an easy part once you have the first part done. Huh? Yep, you could do 9t minus 2. Yep. Okay, these ones are just the hardest to remember what to do with them for sure. So really all you're doing is you're taking your initial point plus you're taking t times your vector. So if you can plot it out quick, your vector just is how far right it goes is your x piece, which makes sense, right? How far right is your x? And then how far up is your y? So you just take t times that, put it into a vector equation, put it into a parametric equation. So you don't necessarily have to write, all of this stuff out in every homework problem. Having it in your notes is beneficial, though, so when you look back, okay? Questions there? Okay, so this is just 10.4, part 1. We'll do part 2 then on Monday, okay? So these homework problems will be due Monday. You can ask questions on them if you got it when we come in, and then we'll do the second part to it.